everyone, First Class Johnston here with the 103rd Aviation Maintenance Squadron of the 103rd Airlift Wing at the Oshkosh Air Show 2024. Behind me, you'll see our beautiful C-130H 3. It is aircraft 1456 with our beautiful legacy paint scheme celebrating our centennial anniversary. The scheme is rather unique, with the black lightning bolt symbolizing our black lightning heritage from the 1941 assistance in China with the P-51 Mustangs, where we earned these stripes. As we go along, we'll also see some other notable features of our paint scheme, which will symbolize our heritage as a flying Yankee in the 103rd Airlift Wing. So here, we'll start from the nose and work our way back as to what we have on this aircraft. I should mention I'm a crew chief on this plane, and I am more than honored to do so. So starting here on the nose, this is our nose radome. This radome can be flipped up, but unlike the C5s, it is not able to load. Under here we have some of our radar and avionics systems, and those systems do get maintained regularly. Of course, here at Oshkosh, fingers crossed we will not have to service them, but they're sitting under here. These lines here dissipate static electricity to that unit. So going along here, starting on the right side of this aircraft, we have our locks system. So this is how we input locks, and we'll also purge the system from here. As a crew chief, we locks rather often, so we can open this panel up. And this panel, locks can be a very dangerous system. It, of course, is liquid oxygen, so if you touch it, you are not going to have a good time. So right now, all our systems are closed. We inspected it prior before we came here to make sure there is no droplets of locks. So this is what it looks like. This is our intake valve, and over here, this is a system for purging. And this is just a bonding wire. They're rather common on the aircraft. They get used to assist with dissipating static electricity, and then also they are an emergency system to, if this panel were to get blown off the plane, there's still hope that this bonding wire could hold it on. So here is our pitot tubes. Standard pitot tubes, like on any other aircraft, give us some indication for the flight deck while flying this aircraft. These are the rose style pitot tubes, so it's the same on the top. What's nice about these is on the older C-130Hs, they're not rose style, so for you to test them, you have to actually put your hand up to it, and they get hot very quick. So now that they are the rose style, we no longer have to check it, which is very nice on us. Under here, we have our LOX vent. So this is, LOX is a pressurized system, so we want to make sure that the system doesn't explode, doesn't get overpressurized, and this LOX vent does occasionally vent. I don't know if we'll catch anything at this hour of the day, but maybe a little later we'll see as it heats up some of the LOX vent out. So this line here is for towing, so it's not an error in painting. It is there for a reason. It is for when we tow this aircraft and we hook up our tow bar right down here in the nose section. We want to make sure that the aircraft, when it is being towed, which it was actually towed here at Oshkosh, is not exceeding this line, which from the aircraft tug, when you see it, it will you'll be able to clearly identify that this spot is not to be towed past. Reason being, we can cause damage to the nose landing gear. So as we move back, we have some more interesting things. Of course, our identifying marks showing our pride as we fly throughout the world serving the United States Air Force. Here, this is one of our jacking pads for a nose jack. The jacking pads actually that we have stay with the airplane. They do not get changed. They sit inside the fuselage of the aircraft, and we'll see those a little later. And and they are installed with screws, which get torqued down to a very safe amount of torque. It's how we do large jacking. So if we needed to do a nose gear swing, we could nose jack this aircraft and allow it to do its swings, and instead of having to axle jack, which would of course not be safe for gear swings. So right behind that, we have here our flight deck air conditioning unit, which is cooling, of course, the flight deck where the pilots and our flight engineer, our navigator, they sit. It's also cooling the avionics compartment underneath, which commonly gets referred to as the hellhole. It is a very tight area, which we'll see once we get to around the inside of the aircraft, and it is all the avionic components for the aircraft and the flight deck primarily sit. So we want to keep that area as cool as possible, and sometimes actually during the summer, when we have power applied to the aircraft, we'll actually have air conditioning, external air conditioning carts blowing air into that area just to keep those systems cool. We want to make sure that everything on this plane is operational, and avionics components are a big component of that, and we don't want to have any damage there. So we can look in there. It's nothing too fancy. This is the ram air intake for it, and on the other side is the exhaust. So as we take a step back from the aircraft, we can see once again our beautiful black lightning bolt. And if we take our attention to underneath the plane, we will see this U. And this U is actually where we will mount chaff and flare for one of the many points of dispensing on this aircraft. So the panels are covered up right now. There's no armament on this plane. But when the time is right and we need it, we can upload chaff and flare to this aircraft. So here, as we keep moving back, this is one of our radio antennas, which is I believe these can have the capability to change. They transmit under UHF, but they can also be used to transmit our JPAD system, which we can show a little later. Right here is our air conditioning oil indicator. It's just a sight gauge. Usually we'll just shine a flashlight in there to ensure that it is all good to go. We have the proper amount of oil in there, and this air conditioner will keep working in flight, which in the summer months is very important. We have a true airspeed bulb, another one of our sensors. It will not cause any damage, not cause a leak, it will not explode. We really want to make sure these windows are safe because it can cause a big problem while we're flying. As we keep going back, we have, of course, our emergency exit for the front of the fuselage. It can be open from the outside, but if you look inside the window there, you will see what we refer to as the lollipop. It is a safety lock, so it is preventing this door from being opened right now. And this is, of course, a primary emergency exit if needed, and we will test it and do the same thing we do with the windows to ensure that the gaps are within limits according to our technical orders. And you can see here there is a little sinking in, and so this was inspected before we came out here to Oshkosh, and it was within limits according to our technical data. We have here the cargo compartment air conditioning unit. So same thing, we have a intake, and we also have an exhaust in the back. Now, you might be wondering what this black line here is, and that is the prop arc. So while these propellers are spinning, going along with momentum, if unfortunately one of these props were to shear off, it would, depending on where it's shear, it could shear into this arc. And actually, when you go inside the aircraft, you will also see lines indicating the prop arc, which is very important. It also gives a signal from when we're sitting on the side of the aircraft where the props are running. It gives us a good reference, because when these props are spinning very, very fast and you see you really can't see the props, you know they're there, this gives you a perfect reference as to where they are spinning so you don't get hit. So we can walk around here. Now, instead of me walking right through this line here, as a good maintainer, you'd never want to walk through your prop arc. While yes, there is no power applied to this plane and there is no bleed air currently in our system, it's still making for a bad habit. So we're going to take a step around the prop arc here to make sure that we're being safe and forcing good habits. As you can see on our external fuel tank, we are of course the Flying Yankees. So we are very fortunate to Air Mobility Command for granting us the opportunity to have our aircraft painted in such a beautiful scheme celebrating our centennial anniversary. So sitting in here is the air conditioning unit for the cargo compartment. This is the exhaust down here. And once again, we're seeing our beautiful paint scheme. And right here, unlike the flight deck, the cargo compartment has a little door with quick release fastener, and you can see the oil level and the safety wire. And there's also another bonding wire on there, as you'll see is very prevalent on these planes. So we can take a look at our landing gear. So this is our landing gear door, which is in the maintenance position right now. So typically the door will sit flush along here against the tire, or not in contact with the tires, but it is sitting flush with the fuselage. So right now, so we can perform maintenance in the gear wells, we have it propped up inside. So right here we have one of our taxi lights. It has a grate over it, a screen, just so no large impacts happen. This door is the same material as the fuselage. So when we take a look under here, we have two landing gear tires on both sides of the aircraft. So these tires are pretty big. They are actually very simple to do a tire change on. The landing gears go in a straight path up. They do not have any rotation like some of the other aircraft, the C-17s, the C-5s. So inside here, this is just a hubcap for the aircraft protecting it. Inside here, we have an anti-skid transducer, which is for our anti-skid system, and we'll see actually the box inside the aircraft. And we also have only one nut holding this entire wheel on. It is, unfortunately I can't take it off for you right now, but it is kind of the savior nut, some will refer to it, as it is the only thing holding the tire on. It is fastened with a screw, so there are safety measures in place for it, but that is really the only thing holding this wheel on. So it is it's a split rim tire, so these tires get rebuilt and they have certain conditions that they have to meet. So typically, one of the most common things that we'll run into, especially with the sidewall, is cord body showing. So it is white. It is not that. That is just a stain. Which cord body showing is an automatic tire change. So luckily on these tires, we of course inspected them before we came out here. There's no cord body showing. You can see also our cut limit, and we have a cut limit gauge inside the aircraft. So you can also see the tread on these aircraft tires. These are new tires, so we have really lucked out here. We don't have to really look too deep, but still, they did get inspected before we came out here. And this is the landing gear well. We're during an aircraft wash. It is not the funnest place to be, but other times it is. It's a little tight sometimes, depending on what maintenance is getting done in here, but a lot of things going on here. So of course we have our tires. We have our torque struts right here, and the same on both sides. They are soft struts. They are serviced with Hydramite, which is the preferred method of servicing. When I went through tech school, we did not really learn too much about Hydramite. We learned the alternate method, which is with high pressure nitrogen. So if you look up on this, you'll see the ball screw and the quick disconnect coupler, which is safety wired. These tires, it's actually a very simple system. It will go up, it will hit a snubber valve, which will slow it down so it doesn't shoot into the aircraft. It will slow the aircraft, the landing gear down, before it comes to a full stop of retraction. We have indicators to make sure, of course, the landing gear is fully retracted. So, or it's on top or bottom. They are indicator switches. They are spring switches. As the gear comes up, it compresses. And that was make sure that we have accurate indication in the flight deck that the landing gear is either retracted or extended. So you can look back here. This is our torque arm up here, and this is to prevent the tires from swaying. And you can see all the lines running off of it. So a lot of the electrical lines, like here, is for our anti-skid, and these are hydraulic hoses for the brakes. So we want to make sure that these hoses have a little wiggle in them, just because it is going to get high pressured hydraulic fluid flowing through them, but we don't want to make sure it can come out. And then of course the solid hydraulic lines coming down. We have our brake restraint chains down here to make sure these hoses don't move and impede gear function. Back here we have our brakes, which of course brake the aircraft when needed. They are powered. There's normal and emergency brake systems. They are powered by our auxiliary and utility hydraulic systems. You can see the indicator pin here, which commonly will get inspected. This is a zero leak limit area, so if there was any suspected leak of hydraulic fluid, we would have to have an eval done. We want to make sure that this is always functional, as this is a very, very, very important component to the aircraft. One of the most susceptible areas to FOD damage, which unlike fighter jets, our planes are able to have a higher tolerance to FOD, which doesn't permit FOD to be allowed, but the most susceptible area to FOD damage is our tires. Fighter jets, of course, their engines are a lot more powerful than ours, and they are more susceptible in their engines. That's why when they do intake inspections, they have to wear a special suit. We do not have to. So here we have our bell crank push rod assembly. This is what is actually moving the gear door, which if you track up and around, it connects down here. You can see that we are in the maintenance position with our gear door. This stick typically will sit along here and in stowage, but right now, since we are in the gear well, the only way we can be in this gear well is with our gear door being in the maintenance position. So the brake hoses, the torque rod. If we move back here, we will see one of our anti-skid systems right back here. That is a anti-skid indicator. which goes to the transducer. That is one of the indicators, which we'll see the box actually inside the aircraft. You can see also the landing gear light, which when you're working on night shifts or mid shifts becomes a necessity. And then also over here we have our SPR manifold. This is the line. So right behind here, we'll actually see the SPR panel, which will open up. This is what's sending fuel up into our tanks. So this is the lines that will do that. There's also a static line to dissipate static electricity. You can see this is our main refueling line, which we don't have a refueling truck here, but the hose is about the similar size, and there's a lot of fluid, a lot of fuel being transferred. This is our transfer line, so if we're doing a transfer between tanks, fuel will be managed through that line. It's a little slower. And then our SPR drain. So of course when we're shooting fuel up into the wings, there can be fuel stuck in the line. So we will drain the fuel down, and we'll have the fuel drain into our a manual SPR drain, which at the end of a fueling operation we will we will drain that fuel to ensure that there's no risk of fuel being near these gears, which the reason being, if there's a situation of hot breaks or a fire breaks out in here, we do not want to have the risk of fuel catching fire, which will cause a very, very bad day for our aircraft. So we can come out of the gears now, get some fresh air. So, and to put this into the maintenance position, the access doors are right there. They're the two circles open. So here you can see our grounding points. There are two, and that is for when we do a refueling operation. We are to ground the aircraft, which is always grounded, and we will also be grounding the fuel truck to the aircraft. We like to call it the triangle of safety, just to make sure the static electricity is constantly dissipated. We will also, there's a whole briefing we will go through to make sure that we are being as safe as possible during this, to minimize damage to all the personnel and then of course to the aircraft. So right now, unfortunately at Oshkosh, we do not have grounding points, and we are not doing a fueling operation. So this is, there's also other points for grounding. Depending on where you go, some places have their grounding points in different locations, so it becomes necessary to ground the aircraft from this point instead of this point. So it's giving you more options here. So this is our refueling panel. We use Jet A or JP8 jet fuel. So if we open it up, you can see this is our SPR panel. So when we do a refueling operation, there's 3 personnel involved. They have a refueling supervisor who will stand at the front of the aircraft. They will be making sure the aircraft's staying level. They'll also be supervising, making sure that there's no abnormalities. If they saw a fuel leak coming out of the jettison mast, they would call that out to me. I will cease the fueling operation, and we would disconnect the truck and notify our expediter that we have a fuel leak, and they would do the appropriate actions. So this is our SPR panel. So I will be plugged in, and so the refuel supervisor with our intercom system, so we can maintain constant communication throughout the refueling operation. I have had instances where we lose electrical power during the refuel, and that's a case where, of course, we're losing communication. So that falls on me, the SPR operator, to cease the fueling operation, because we don't know that if the tank pumps are still working or what's going on. So we're going to cease all fueling operation here, and of course we're going to reassess, and we're going to go off what our supervisor deems is the best option. So this panel is fairly simple. So of course we have a light for nighttime refueling. We have a crossfeed ground transfer switch, which is important when we're transferring fuel between between tanks on the ground. These are our tank switches to determine if we're going to send fuel. So of course we have 1, 2, 3, and 4. So on this side we have tanks 3 and 4. And we also have our left and right auxiliary tanks. So the auxiliary tanks sit right under there in the wing. You can see the yellow circle and the red magnetic sight gauge. And down there is how we can manually indicate or manually check the auxiliary tank levels if we were to have a gauge failure. And then we have our left and right externals. So we have our offload valve, which allows us to send fuel, and then we have our master switch. So right now it's off because there's no fueling going on. We could rotate this to pre-check prime, which is testing the fuel shutoff valves inside the aircraft. When we do that, we are making sure that when the aircraft hits maximum capacity of fuel in the tanks, that they automatically shut off. It's actually a pretty cool process. I've only done it twice in my short time in the Air Force so far, but it is a very necessary thing to do. And then of course we have the most common, the refuel ground trans. So if we're doing either a refueling operation or we're doing a ground transfer, we will rotate this master switch there. Then pre-prime second, so this is just a secondary check to make sure that the fuel tanks are shutting off at maximum capacity. Off, of course, which the switch is, it's in normal position. That is, no electricity is being sent to this panel other than this cannon plug with our comm cord. Then we have our defueling operations. So if we need to take fuel from this aircraft for any reason, typically it's a maintenance action, but there are times that the aircrew operations will need less fuel on this aircraft. And then drain, which we were talking about a little earlier. So the draining of the aircraft, as we send fuel up into the wings, we want to make sure that there's no fuel remaining in those lines. So we will drain with the drain pump all the fuel down, and then that will come down here to our SPR drain, which will actually drain down here in these drain ports. And of course, right now we're not going to do that. This plane was refueled and drained before it came here. And if we were to refuel when we go to leave Oshkosh, we're going to have to put on the proper PPE to ensure that we're not getting any contamination on ourselves, which jet fuel is not the safest for humans. And then right here we have our intake. This is where we would hook up our refueling hose, and we can take on fuel, send out fuel for refueling or defueling operations. This is just a quick overview of some of the procedures that we have for refueling. We don't go off of these. We have more accurate technical orders that we will use to refuel. Of course, whenever we're doing any type of maintenance action, we are gonna 100% make sure that we're following those tech orders. We want to, it's a very good privilege we have in maintenance that we have the opportunity to stop maintenance, right? If during a tow or during a refuel, if something happens, I can stop. In the air, you don't have that opportunity. You got to keep going. The plane can't stop. So in maintenance, it's an area where we can control as much as possible. We can control our risk factors. We can control what is happening, and why go into a test, an open book test with no notes, then go into it with the notes right in front of you. And that's exactly what our tech data is. It is the answers to our test. So it tells us exactly what we need to do. It allows us not to be wondering, well, what should we do in this situation? What do we need to do if this happens? What happens? It tells us right there, which is a very, very nice privilege that we have in maintenance. So, and there's also another grounding point in the panel as well. So now we can start looking at the wing of this aircraft. So like we were speaking before, that is our magnetic sight gauge to manually check the aux tank. So we can see how much fuel is in there if we were to have a gauge error. Up here, these two large square panels, those are another area of chaff and flare dispensary. So as you can see, they're paneled up right now, but there are times where it becomes necessary. We'll upload chaff and flare to this aircraft, and that is where one of the areas it will dispense from. So you can see up here that large circle opening right there, that is a fuel vent. So that is, so of course fuel is getting pressurized through heat and expansion. So we want to make sure there's no soot trails there. We also, and also if there's enough pressure, it will actually drain fuel out. It'll pour out of the aircraft. So the soot trails would indicate that there's a tank fire. And of course, right now we don't have any, which is very, very good. But if we did, we would go about notifying the proper authorities to make sure that the system is safe and that we contain the spillage. So now the long-awaited engine portion. So unfortunately, we don't have a stand right now to go up and show the inside of the engine, but we can talk a little bit about it from the ground. So this is a T56 Allison engine. These are turboprop, of course. It is a constant speed operation, meaning that our aircraft, when they are flying, they do not change their RPM. The only thing that changes and how we can manipulate our airspeed is with the pitch of the prop. The H models are controlled with hydraulic fluid. You can see here on our number 4 engine, our propellers are at a perfect length. So they will just reach under supersonic speeds at full RPMs. So if you look at the bottom here, this is in a aluminum material that is the props are made from. And if you look up at that black part of the prop, that is actually the anti-icing. So of course with our props we cannot use bleed air. There is bleed air anti-icing systems throughout the other components of the engine, but for the props they cannot use bleed air. They use electricity to de-ice, and they have a boot. On the C-130Js, the boot is also on the tail. On the H's, it is not. So what happens is it pulsates energy through the brush blocks on the prop to knock off any ice that comes on this prop. So it is actually foam with a hard plastic exterior that you're seeing right there, that black. So if we saw any foam exposed, that would drive an immediate evaluation of the prop to make sure that is serviceable and we can fly safely. So these are our 4-blade Hamilton standard props. They had the foam, the icing. The prop actually, once it hits that black area, it starts to V, but it's not like a V. It's more of a cone going into the prop barrel, and then it contacts that brush block to get its electrical power to de-ice the propellers. Of course, on front where that red intake cover is, that is where we get our intake into the compressor section of our engine. So underneath here, this yellow flap that is open, that is the oil cooler flap. So right now it is in the full open position, and it is to keep our oil system cool. The engine works pretty efficiently, and how the engineers designed it, it allows for the cold fuel to go next to the hot engine oil. So it's warming the fuel, and it is also cooling the oil. So it is pretty unique. The oil cooler flap, of course, is helping to cool that oil, which gets circulated throughout the engine and is very, very warm. And unlike our newer models, the C-130Js, the C-130H has a hydraulic, our propellers are changed with hydraulic fluid instead of the engine oil. So up top, you can see our access panel is one of the biggest panels there. When we do our inspections, we'll open that panel. We'll check our drain plugs, our starter on the 3.5 mod engines, our starter engine oil, or starter oil, sorry, quantity. We'll also make sure that there's no FOD in the engine. We'll make sure there's no broken components, no leaks. Speaking of leaks, you can see underneath here our sabo drain. So our aircraft, they do leak fuel. The reason being, the aircraft is gravity fed, meaning that engine fluid is always going to the engine. So the fuel shutoff valve opens at 16% of maximum RPMs and allows full fuel to the engine. Right now it is just dripping, which is allowed. It is within our allowable limits per our technical data. And so that is also where if there is another leak from a hydraulic component, oil, it would also all funnel right down there, along as the two vents as well. So behind that, so right where you see that split after the sabo drain to what we call the clamshell doors, that is the hot section of the plane, right, to refer to. That is where the combustion of the engine, and of course behind it is where the exhaust is. So the compressors, it's standard jet engine operation. So it is a compressor that is compressing the air. It is getting sucked. It is sucking air in, compressing it. It is getting sent to the burner cans. There are 6 burner cans with igniter plugs, and the igniter plugs ignite the fuel. So right here, this is our external fuel tank. So once again, with our beautiful Flying Yankees logo on there. The external fuel tanks were a new addition to the C-130Es, and then it was carried on to the H's. These tanks cannot be detached like a fighter jet's. They are fixed, so they have to be ground mounted. They could be removed, but it would greatly reduce the aircraft's range. It is similar to the certain models of the C-130Js. The Js do not have external fuel tanks, but some models can be adapted with it. So if you look on the back there, you're probably curious as to why there is a panel, if it's an access panel. Well, that's actually another point of chaff and flare dispensement. So it is, of course, covered like all other chaff and flare dispensary points. And there's another area where you can dispense chaff and flare on this aircraft. So the flaps are retracted right now, but when they go down, it is a very, very big flap. And that's why our planes can go into such short runways and take off in such short runways, and on soft fields as well. So right now, the flaps are retracted, but you can see our paint scheme. We have the invasion stripes, which was awarded to our unit in 1944. And the invasion stripes are on the aircraft. It was a way to minimize friendly fire on our aircraft going into Normandy. So that was awarded to our unit, the 118th Operations Squadron, in 1944, which would carry on to our 118th Operations Squadron, and which falls under the 103rd Airlift Wing. And so we are symbolizing our heritage with those invasion stripes. So as we continue to press back here, we are coming towards one of the control surfaces, that being our ailerons. And you can see with our ailerons the static wicks. Those 4 look like strings, a little broken there. Those are 4 static wicks on the aircraft. Thank you, sir. You can also see at the end that big tube right there. That is the jettison mast. So these planes can dump fuel if needed, and when they do dump fuel, it shoots out a lot. It is a lot of fuel. On top of the aircraft, you'll be able to see in the dry base, actually that mast, how much fuel is going through there, and it is a lot. It is a lot of fuel. And then on the end, just like any aircraft, we have navigational lights to signify which side of the aircraft is there, and then our wingtip taxi lights as well. So and then you can see those two circles, and those are the fuel vents as well. If you look at that, looks like an anchor. That is another point for mooring on this aircraft. So when it is necessary, we can moor this aircraft down. Typically, the nose chain is the most common time we'll moor, but we can also moor this plane, depending on what circumstances it is, from the wings and the tail. And our technical data has the allowable limits depending on the circumstances for us to moor the plane correctly. Which is one very nice thing about aircraft maintenance in the Air Force is everything is, of course, by our technical orders, which is very, very important. Run so we don't mess up, correctly fixing a part. But on top of that, it also allows us not to have to memorize data, not jumping through hoops. Right? As a crew chief, I am a general systems mechanic, so I work every system. I have a general knowledge of every system, and I have a general ability to work on all the systems. But with that, right, comes a lot of memorizing things, and there's a lot of components. So having tech data allows me to not have to memorize those components and be able to fix them correctly. So we'll be around here. So we're working on our external fuel tank. The number 3 engine is similar to the number 4 engine, of course. If you look right here on the inside, you can see our landing light for the aircraft. They are extended and retracted when needed. It is currently retracted right now. So as we keep moving back here on the aircraft, you can see our air deflector doors. So right here, these are they're closed currently, but these are the air deflector doors. These doors behind this one, since it's the SPR single point refueling panel side, we inside have a surge suppressor, which is an emergency boost of pressure to the system if necessary. And it can also dampen surges of pressure coming into the system in case there's an overage. So these doors open. Their primary function is when we are deploying paratroopers. The doors will open and deflect air from the paratroopers. So they come out to around here in line with the fuselage, the wheel wells, and they deflect air. So as the paratroopers jump out, they can clear the plane and go back instead of getting a hung chute where someone is back there. So this is our parachute door. It is currently closed. It can be operated from the outside. There can be a lollipop, like we were speaking before, but right now there's not. So these doors can be opened. So it can be operated from the outside. It is quite a feat to do that, as these doors are pretty heavy and pretty complex to open. But this is ultimately where paratroopers jump out. If we are doing a paratroop operation, we will install a jump platform to extend the cargo floor out for the paratroopers. This is moving towards the rear of the plane. This is our toilet servicing, so we do have a toilet. We do not have a urinal like some of the older model C-130s. I'm not going to open that. It is a little nasty. So, but the plane gets serviced just as any other aircraft would. So here we have our LERCM system. So this is one of our electronic countermeasure systems here on the C-130. It's a rather unique system. It's not installed right now. That's just the covering on it. When we go into forward deployed locations or areas where there could be hostilities, we'll upload that on our recent deployment. We had LERCM installed, and it did get some use. So as we keep moving back here, we'll move to our stabilizer. So this is, of course, very high up off the ground. When we go on top of the plane, we can see really how high it is. And it's, whenever we operate up there, we always take a lot of safety precautions. And of course, risk management is number one, because it is a big fall, as you can see from the ground. So as we keep moving back here, we have our elevators. They're very big compared to some of the other aircraft we have here, maybe not as big as the C-17s. And then we have our static wicks on either end. There's 3. They are dissipating static electricity from this aircraft while it's moving, because of course how we look at air movement in the air, it is building static electricity, so we need a way to dissipate that, and the static wicks is how that's done. You can see they're frayed at the end, and that is acceptable up to above 1 inch. And we always reference our tech data when we're doing that, and those are within limits. Trim tabs are standard trim tabs, up, down, and they can also be controlled from our control wheel, which is very nice. Then in the back here, we have some we refer to as the beaver tail, because it looks like a beaver's tail. And they have some other countermeasure systems, some sensors, and then other units that are covered up right now. So, and then you can see on our rudder that there is also static wicks, 2 on the bottom, 1 up top. And if you look on the top, actually we caught this right before we were flying out, the static wick is, it's there, but it is pretty degraded. So it's within limits, we can fly with it, but when we get back, we're gonna have to change that out. So that was a good catch by one of our crew chiefs before we headed out. So here is the ramp and door. It is now retracted, it is closed. So it is it really is massive when you look at it from the back with it being up. So with that, we have some more mooring points up top. We actually have that circle right there. That is a jacking point if we choose to jack the aircraft from there. We also have this big circle here. This circle is a depressurization vent. So in air, not overpressurize the aircraft. It will release air as needed, but it is also when we do ground pressurization for testing a system, if in the case that the pressurization system fails, we will use our prop stick and shove it up in there to release pressure so the people inside the aircraft do not die from the overpressurization. So as we come to this side, same thing, our elevator control surface. We have our trim tabs, our static wicks. We also have our LRCM once again. On the bottom here of the aircraft, we can see that we have some antennas. These are mainly avionics systems and some detection units. Similar to the other side, our paratroop door, we have an air deflector door right here, which we use to dissipate air for paratroopers. Same concept, but it's the other side. This air deflector does not have the surge suppressor, so only the refueling side has a surge suppressor on it. As we come here, we have another locked liquid oxygen vent. So as stated previously, that system is stored in a reservoir, which we'll see up in the nose, and it does bleed pressure, just like our fuel systems and hydraulic systems. Now this panel right here, this is a hydraulic panel. So this is what we refer to as the ground test checkout valve. So this valve in here, open the panel. This handle right here will be turned down when we want to operate flight controls on the ground without engines running or a hydraulic mule. So this system allows us to tie two of our hydraulic systems, the auxiliary and the utility, to operate our flight controls. The flight controls are controlled one half in normal operations with the utility and booster systems. However, when we are on the ground, it becomes necessary, and I should stay with the out engines running or a hydraulic mule, that we have some hydraulic pressure coming from a system that can be run without engines or the mule. So that's where this valve comes in. It allows us to take pressure from the auxiliary pumps and bring it to the utility system through a valve that is right behind here. Some refer to it as the octopus valve. It is an 8-way hydraulic valve, and it takes all the pressure from the aux system and brings it to the utility. And we'll see those centers in the aircraft. So when this valve is extended, it will not allow this door to close. So this can only be done on the ground, hence the ground test checkout. It is only for ground operations, and this is the primary means in which crew chiefs operate, and really all flight control surfaces get run on the ground in normal conditions. And then here we have areas for hydraulic troops to use their systems, and then hydraulic lines running. Close that up. And once again, the theme with the bonding wire is very common throughout the aircraft. So in here in the landing gear well, only on this side, there are two fire bottles. They are halon. There's only two, and we have 4 engines. So if there is an indication of a fire on the aircraft, and we'll see this when we get into the flight deck, the operator at the time, depending if it's the APU or an engine, will pull the T-handle. That T-handle being pulled allows for fuel to be shut off to the engine. It will also feather the props if it is a engine, and it also gives the ability to discharge these squibs. These fire bottles, they're circles full of halon, and they will dispense as necessary to the engine or the APU. So if we come under here, and if we look, it's going to be hard to see because of the lighting. Let me grab a flashlight. All right. Let's see if we got. It's going to be. Let's see from here. It's probably best if we get it from the front. That's actually where the gauge is. All right. So, if you come at this angle right here, you'll be able to see the little white gauge and the brown bottles. Yeah, it's hard to see it. So right up there in this left-hand landing gear well, there sits 2 squib bottles. They sit forward and aft. They're pre-charged with halon. These can be dispensed when needed to combat a fire in the APU or engine. Right up here is our APU. This is our APU exhaust, which is covered right now. And then right here is the intake for our APU. So this is actually a door that will open and allow air to be sucked in. There's a screen right here to prevent foreign objects from getting sucked into this APU. And it will suck it. It looks almost like a French horn. This type of engine is a turbojet engine, and it will provide bleed air and AC electrical power to this aircraft when needed. It is the same generator, AC generator, that is in the engines, so it can be used in emergency situations to provide AC power. Up top here in this access panel, we have a bleed air connection. So if we wanted to do a hot start of the engine with bleed air, if a Dash 95 cart, we could use that right here, or provide bleed air to the systems for bleed air checks, or any bleed air requirements. We could test the environmental systems, things like that. And then down here, this is actually where we have our APU quick access panel. So right in here This is the oil compartment for our APU. It is rather a pain to fill it, but luckily the APUs don't burn oil that much. So this is a sight gauge indicating our oil quantity. We can also, this is the filler neck here, and right up here is our APU. So the armor and placa, which I was talking about earlier, so due to the special paint scheme we have on this aircraft, the armor and placa was temporarily put here. Typically it would be a black square located right here, so any crew entering this aircraft would easily be able to identify armament on the aircraft. This is written in a grease pencil, and you can see here some of the previous munitions that were loaded. These are not installed, but there was chaff and flare installed on this aircraft at some point. This is our crew entrance door. So this is the primary means for crew to enter the aircraft. You can see we have a temporary exit sign as we're here at the Oshkosh Air Show. Here we have two latches, which when they are operated, do have a slight retraction back. It's very hard to tell, but they do retract. And then this door can be closed from the outside or the inside. If it is closed with the inside, it will utilize this cable right here. And if it is closed from the outside, it will be closed as such. So this door is also inspected to make sure that the gaps are within limits. We'll do that on our inspections regularly. See here, it's a little protrusion, but it is within limits. It was verified before we came here. And then down here we have hinge access panels for this. Same thing here. And then we have, once again, one of our chaff and flare dispensary pod mounting areas. So to open the door, we'll just verify no one's on the other side, let them know we're going to open, and slowly release it to the ground. Right here, we have our external electrical power adapter, so we can take on AC or DC power, external power, with a power card at a -60 or a -86. And this is our battery compartment. So this is our battery right here. There's two batteries in this aircraft. One is for the skin system, and one is for the normal aircraft operations, and of course this being a battery is DC power. And once again we have our pitot tubes, our rose style pitot tubes. We have here another grounding point, and we also have a comm headset port, so we can plug in our headsets here and run communications for ground operations of this aircraft. Down here we have battery vents for the battery compartment. So if we come in here, mind the tight space, and since there's no power we cannot use the light, but if we can start from back here. So back there, to make sure that the landing gear is down and locked completely, we can't see it right now, but there is a plunger. It is a illuminated plunger on the back of the aircraft, on the back of the landing gear actuator, that will indicate that this gear is fully down and locked. And then you can see here the drag arms on the
landing gear. Here is some of the belt crank assembly for the nose landing gear aft door. Here are the hydraulic components for this nose landing gear. These are on either side the steering actuators, so that's how this aircraft steers, which if we follow that cable up, it goes up across here and it goes right up here to this chain, and that is controlled by the tiller and the flight deck, which we will see a little later. So here, you might be wondering what this red remove before flight tag is. That is this pin right here, the nose landing gear safety pin, which is installed to ensure there's no accidental retraction of this gear while it's on the ground. So these are the hydraulic components. Now there is no brakes on the nose, so for any new crew chiefs or new maintainers out there, when you get told to change the nose landing gear brakes, try to find something else to do. So down here, this is another soft strut. It serves with hydramite. This is our scissor arm right here. When we were talking about the lines, this will get disconnected on the aircraft. So this gets disconnected, and we can disconnect it right now. Actually, I'm gonna remove my ring, as that is not safe maintenance practice. Okay. So this scissor arm is actually a fairly simple design. The arm will get pulled back. And this will turn. Now this would, on a towing operation, normally get stowed appropriately. So, and then the scissor arm will go back as such. Then down here we have our tow fittings, and we have the latch that holds the aircraft while it's flying. So when the gear retracts, it will be held here, and when we tow this aircraft, it will be held by the tow bar right here. These two circles are for mooring the aircraft, and they're also replicated up here. And this is how the aircraft gets moored from the nose. So now, if we look here, we can see the forward nose door assembly. So these are our arms for the forward nose door. We want to make sure that there's no excessive twisting. So this is acceptable, but if I was able to get full revolution, that would indicate that the tab washers, which if you ask any crew chief about tab washers, they will probably stop talking and start running. They are a pain to change on, especially on this door, and this is the most common area where tab washers get broken. This door can be lowered for maintenance, and then of course it is used to secure protect the gear while in flight. So here we have our hydraulic components, and we can make sure that the hydraulic components are, of course, not leaking. But the reason there are so many is, of course, that is how the nose gear gets retracted and extended. But also, if you look here at this big cylinder, that is a emergency brake accumulator. So it is serviced with high pressure nitrogen, and the purpose of it is to supply an emergency surge, or two reasons. It provides an emergency surge of pressure, and it can also take on surges in pressure from the system and combat it. So it remains at that pre-charge. Typically, when the system's actuated, it will bump up a little. There's an acceptable range for static use, and it's plus or minus 100 psi. So all these accumulators, this is the emergency braking system, have, of course, hydraulic fluid and air. It's a unique system. It has a steel block that can send the pressure, if necessary, to the hydraulic fluid. Of course, there should be no air in the hydraulic lines, as that would indicate that there is a massive leak in the system. So here we have our nose steering chain and cables. This box right here is where our battery compartment is. We opened that a little earlier. So we go here. This is the attaching point for when the gear is retracted. This is where it will clamp onto that little fitting down there and hold this landing gear up. Now over here, this big dome is our LOX unit. So this is where the LOX is stored on this aircraft. It is a maximum capacity of 25 liters. However, usually we sit around 24 liters of LOX. LOX, of course, being liquid oxygen, which we turned into GOX, gaseous oxygen, for our aircrew to breathe in emergencies. So right there, that panel, we opened that a little earlier. That is where we service the LOX system. Down here, we have another accumulator. This is our normal brake accumulator. So this one sits at 1500 psi. So the accumulator function here is the same design concept, just a little bit more pressure and a different system. And then up here, we have some electrical components for our radome, which is sitting right here. And there's avionics components and some other systems that run in there. We have static lines to assist with dissipating static electricity and static in our aircraft, and then hydraulic lines. Now looking up on the ceiling here, you can see our access panels. These are for our flight controls. These allow us to rig our flight control surfaces, which sit right under here in the flight deck. You're probably wondering what this is up here, why it's not up here. So this is Velcro. This is male Velcro. It is the hard side of Velcro. It allows for the mounting of armor. So when we go into deploy locations, and it is necessary, we will mount armor to our aircraft in case this plane does take fire, so it will not penetrate into the flight deck. This is another access panel for us, and we will bolt the armor down and also stick here. It is possibly one of the most physically demanding jobs crew chief will do, but it is necessary, absolutely necessary to do. It does add a good amount of weight to the aircraft, but it is important. So that's all for the nose. So with the ramp and door down, we can go down. So this is, of course, for the loading position right now. So the ramp would normally sit in normal operations in the ADS position, which is the aerial delivery system position. So that is, it is in line with the fuselage. It is not sloped down. Obviously, we cannot fly with the ramp being down like this. We can fly with it being the ADS position. Here, these are loading ramps that we have. This allows us to wheel items onto the aircraft. This is typically done by our loadmasters. They're stowed right now as you're not loading onto the aircraft. And then up above is the door that we saw earlier. So it is stowed for maximum space here. On the side, these are our rails. These latches over here, these yellow, allow us to hook onto pallets. So if we have a pallet and we are going to roll it out, it'll hook onto here so it doesn't shift in flight. And when they release it and they're wanting to drop it, they will shoot the pallet out whatever system they want to use. So where the door is covering up right now, that is where our elevator and rudder system boost packs sit. They're blocked right now, but with the door down, we're able to see that. Here you can see this big steel cable, and that is for our paratroopers. So the paratrooper cable is of course for static line jumping. Along here on the longerons here, you can see some extra mooring devices. The cable being up is stowed currently, but it can be rotated down. With it being rotated down, the door cannot be operated as it will crush the system. I also see the flight deck recorder, one of them, on the orange box there. This is where our door is actuated hydraulically. Here is extra stowage of engine oil. This here is our auxiliary hydraulic pump, which is part of the auxiliary hydraulic system. This is the auxiliary hydraulic system center. So this is the reservoir up here. That is where all the hydraulic fluid is stowed. It is not pressurized. You can see the sight gauge. The sight gauge is low right now, and that is because the door is operated. So it is drawing fluid from the reservoir and putting it into the lines, and that is how this door is being opened. And then when the door is closed in its normal position, that reservoir will go back up to its normal acceptable line on the sight gauge. So this is the overflow pan. So if for whatever reason that system gets over serviced or there's an overpressurization, it will drain into this pan. We can also manually drain it if it's necessary to purge that reservoir. You can see also the filters we have here. So more mooring devices, escape hatch. This is some of our Loadmasters equipment here. Right here, this is where we can operate the ramp and door manually. This hand pump here, it can be actuated with this little actuating assembly down here to put pressure into the auxiliary system. It has a direct sight gauge right here, and we're indicating no pressure. We can also operate this with the hydraulic system being on, an electrical system, and then that drives the hydraulic system. We would turn the auxiliary pump on, that blue unit we saw there. And for us to bring the ramp all the way down, as you see here, we would actually need to use this handle. Fun fact about this handle, it is actually made by Schwinn, which makes bicycles. And the rails handle is made by Harley Davidson, which you can see right here. So this is where the ramp is controlled from. You can see the door, with the door of course being operated. The controls are not in their normal position. This is the dial which we would indicate what we want done to the door. If we want it to be in the airdrop position, which is 3N, we are of course past that right now. The door handle, which indicates if we're going to open or close. This here is a communication cord. So this is, we were talking about earlier, goes into the cannon plug. We saw one in the front of the aircraft. We can plug our headsets, our single point adapters into the headset and communicate via push to talk, or if it becomes necessary, we can also pull on our comm box here and hot mic ourselves, so it just picks up all transmissions over a certain decibel range. This is our wafer switch on this comm box, which is primarily used for the load masters. It is only for the interphone, but on the flight deck ones, they are able to rotate it and communicate on different channels. They want to communicate on the UHF, the VHF, and then this call button. This is almost you need to really say something and everyone else is talking. If you hit that, you put your voice over them, it'll block them out. You will be the one speaking. And this is for our jump lights. This is a control for the load masters. So here we see more of the hydraulic lines. Those troop platforms I was speaking of earlier, they are stowed right up here. And when we do troop jumps, they will be employed as necessary. So we can see also up here the push rods and cables for our control surfaces. So those are right up there. You can also see the nose gear lock. And if you look at that little yellow tab there, that's a flag. That indicates that that door is fully up and locked. And we just have one single up lock right there. So here, these are some much bigger mooring devices. More hydraulic lines than this. We were talking about earlier, the hydraulic or the toilet servicing latch. This is the actual toilet that we have on the plane. It has been serviced, so I know it is clean. It's down like so, and you can stand up there and use the facilities. It is a normal chemical toilet, so it is just like any other aircraft toilet. Not the nicest, but we do have some toilet paper and these Sandy packs, which dampen the smell on especially long flights. So right here, these are our life rafts. They're copper safety wired, so if they get deployed, we will know that they have been deployed, and the servicing tags for those. Just like on the other side, we didn't go into it, but right here, this is a oxygen regulator panel. So the LOX reservoir that we saw, this panel will have LOX in it. We have turned the manual shutoff valve to the LOX, so there's no pressure here, but the system can be in on or off. Oxygen can be at 100% or normal oxygen levels, and then emergency mask test is probably the most common it gets used in, and then it remains in emergency. So there's regulator here, regulator on this side, two for each load master, and then there's two up front as well. So we'll close this up. So this is one of the paratroop doors, open right now. For this door to work, it slides in a track with a cable reel. It is, of course, a very heavy door made of all metal. So especially when there's armor on there, it is even worse to put on, and
move up. So to actuate the door, there's a simple system. This pin right here prevents the door handle from being engaged. We remove it and put it down here. This door being up, we will pull it down and we will gently lower the door. And to lock it, just move it down. I use the word gently as when there's actual use for this door in air, it does not get treated as well, which is understandable. But on the ground, when we can control it, as with all maintenance practices, we will be as gentle as possible, as these are a pain to change and fix, especially with the springs that they use. So to open it, same procedure. So we will open. We're gonna pull here, up, and put the safety pin so this does not get actuated. So that is our parachute door here. These are our Loadmaster crash-worthy seats. So these seats where our Loadmaster sits, they can be swiveled out. The parachute door, same operation on both sides here. Our static line cable, which is right here. We can also see some of the jump controls. So for the jump masters on both sides, the jump lights, which are tested when we're doing jumps. More of the controls for the lines. Here we have the emergency lights. So these are very important actually for flight operations. So in the case that there's an emergency, we need to egress this aircraft. These lights will automatically turn on, providing light to all the exits on the plane. So this parachute door is an exit. There's also an emergency exit up here, and there's also one that is blocked currently by the cargo door. So looking up here, these are some of the override switches that we have. So if we wanted to take the doors, and when the doors are operated with power being on, they will indicate whether they are open or closed. They are copper safety wired, red guarded switches. But with them being closed and power being on, we know that they're safe, their safety wire's not broken. The emergency exit lights are also, they get checked every basic post-operation pre-flight. Here we have a first aid kit, which is sealed on the aircraft, so we know it is safe. We have some of the computer components. This big hose up here, this is one of the environmental hoses for bleed air. You can see at the end there is a outlet. This is so we can either have heat or air conditioning on the aircraft. So up here we have our emergency escape hatch with the emergency rope for egress of the aircraft. This line right here, this is for us to mount stanchions or litters, depending on the configuration that we need for the aircraft. We'll see some of the configuration in the front of the plane, and these are cabin lights for us. So here, these are stowed right now. These are rollers. So this is for us to roll pallets onto the aircraft. They are stowed right now. We are not loading any cargo during this time at Oshkosh, but if we were, we would drop the rollers and be able to load. So these are our emergency oxygen system. So unlike in commercial planes, which if there's a loss of pressurization, cabin air is supplied from the cabin and masks, we do not have that. So we have this hood
that gets put on, and it will supply oxygen for 10 minutes to a user. Here, these are some items we use for configuring. This is for our cargo compartment lights, and then also this allows us to actuate the or control the ramp and door and trim tabs. These are circuit breakers, so if we want, we can pull them. So the booster system, we have the primary, this is the primary way the flight controls are operated. Of course, it is split, so if we do lose booster pressure, and it has happened, we can use utility pressure to operate flight controls. The booster system, same concept, a little smaller. Reservoir is sitting at its appropriate amount. It will be, of course, you can extend 1 inch past the full mark, but that is it. And the reason is we don't want this reservoir to be over-serviced and fluid to just spew out everywhere. There's more hydraulic lines, indicators, pumps. This one is cool though, because it runs directly and only off suction power from the engine or from the hydraulic mule. It has 2 drip pans, so this is primary booster, and then down here is for suction. And this also has an accumulator, which is appropriately serviced. And down here's another drip pan. This here is for our main landing gear to unlock it, and then this is the stub shaft to spin it. The same concept here with the speed handle as well. Here we have one of the seats. This is just rolled up and stored, but if we need to, we can deploy all our seats. Or avionics systems. We have our prop stick right here, which is very important. It gets a lot of use. Here we have an emergency escape. This is a parachute in case we need to egress the aircraft in an emergency. A bunk is used for stowage right now. Another emergency exit light. Then back here, we just have the locks manual shut off for our aircraft, which is shut off right now, so the safety wire is missing. Then another reservoir, and 2 more regulators. And we have our aircraft toolbox, and we have the milk stool with winch. So this here is an emergency escape hatch. This is for emergency egress. There's a light. You can see the lollipops are installed, so this will prevent the aircraft. If I try to go down here and turn the handle, it can't be turned. That's so we can keep people coming into the plane, and also it signifies that we don't want anyone coming on. Here we just have some earplugs for when we take on passengers. This is one of the retrieval systems for the plane. This is the winch. This is one of the escape axes, another fire bottle. What's interesting is when they are using the rails, of course if there's a pallet in here, they can't be behind it in case they get hit. So to operate the right side of the aircraft right rail system, it's operated from back here. So they can use the rail handles there and right here to operate the rails correctly. Here we have another communications box. So this has the wafer switch where we can communicate on different channels. So if I want to speak on HF, I would pull this so I can hear HF, and then I would use this HF button on the wafer switch, or I'd move the wafer switch to HF and communicate. We'll put it back on intercom so we're not transmitting to the world, and then so we're not hearing the world. Same concept, you can adjust the volume, hot mic, intercom, you can listen, you can not listen, depending on who you're with, call button. Here we have the emergency nose landing gear extension, so that is also copper safety wire down. So it's sitting in normal. If it gets broken, we know it has been used. So here we're in the galley, not as luxurious as C5s, C-17s, but it gets the job done. Here we just have some stowage for the plane. One for our DCCs for this aircraft and our ACC. Down here we have just some stowage, some prop heating, adapters. Nothing too crazy down here. Here we have the crew entrance door, of course. This is the galley floor for this aircraft, so it is stowed. It does not usually get put down, but it could. You'd have easier access to the galley. Here another emergency exit light. Up here we just have some forms and documentation for the aircraft. Here, this is where I guess the cool things happen. So here, this is a refrigerator, but we are using it for stowage. We have it pulled and collared. More stowage of items. This is a oven. This is operational. We can use this oven, so there's nothing in there. It's a little messy. It did get some good use. More stowage. This is trash compartment. And then up here, these are just our controls for more of the systems. Nothing really special up here. Just some of the switches. This is a water jug, but these will be removed from our aircraft to help with weight. Up here, just more stowage, access panel. So that's all for our galley. It's nothing special like the C5s or some of the other aircraft, but it gets the job done. Down here, under the crew entrance ladder, this is our hellhole. So this is where all the avionics components are. This is not a fun place to be at all. Right down here is the window we were talking about earlier for the nose landing gear. But yeah, I don't personally spend too much time down here, but when we were working with avionics, sometimes they'll throw us down there. It's not a fun time. Since this aircraft, we have the nacelle maintenance overheat indicator right here. And then we just have for the crew door the override switches we had in the back, the light, and then under deck lighting. And then we also do have hydraulic components that run through here. So on inspections, they do get inspected. We can close the door.
Well, during the desert storm, we had big painted
this wire.
fingernails.
Probably not the best time to close the door then. Is there anything plugged up here? I'll just throw it up. We're just gonna close it from the inside real quick. Thank you. So that's the door closed from the inside. Nothing too crazy, just aircraft wire. And then to close it, let them know we're coming back out.
All the big airplanes, we got a big gray one, we got some big green ones. Come on, come on.
Listen, have a good one.
So that's it really for the galley.
Hey guys, Captain Zlotnick from the Connecticut Air National Guard, sitting in the cockpit of C-130H. It's a pretty capable airplane. It's fun to fly, and just going to show you a little bit about the cockpit today. So over here on the left, we have some switches for our lighting, oxygen panel here, paratroop bell, air deflector door switches for when we drop troopers out the back, We have some of our comms set up here to basically control all the radios, volumes, and what radios we're listening to. Here we have our nose wheel tiller, basically steers the airplane on the ground. Pretty simple. Up here you get your yoke, trim, flight displays. Top one is an attitude indicator and the bottom one is an HSI. You get your trim settings here. G meter is kind of tucked away over here. You can kind of see that there. Standard 6-pack if you're into aviation. Pretty much have the same thing here that most airplanes have. You got airspeed, altimeter. I already talked about these two, radar, altimeter. Here we can control what nav source we're using to get our course guidance from in the airplane. You got a backup attitude indicator there. Here we have our engine stack gauges. You can read them off, but you got torque, RPM, TIT, fuel flow, and then engine and oil pressures on the bottom. This is called our macaws. Basically tells us if anything good or bad is going on with the airplane. Coming down to the throttle quadrant, obviously this is what controls the power. Mainly use torque as our indicator. We have certain pitch and power settings that we'll kind of shoot for. It gives us a known, either known airspeed when we're flying formation. We'll shoot for a certain torque to maintain formation positions and things like that. Here we call this skins. Basically controls radio frequencies. We put in different nav source frequencies here, which correspond to this knob as well. This navigators can program a flight plan. We can do direct two-way points like many airplanes, but it is a little bit older technology. Moving over, you have your landing gear lever, landing lights, flap indicator gauge, cabin pressure, altitude there, and then basically the co-pilot has a lot of the same instruments as well. You get your hydraulics on the bottom. You get pressures and indications there of what's going on with your hydraulics. Over there you see the radio panel. That's towards the right half of that lower panel there is for some secure radios we'll use. And then you get your ski panel set up there on the left. We use that to fly formation in the weather with other airplanes. And you see the same skins radio panel there that the co-pilot has. And then moving over to the right, you see a lot of circuit breakers, same oxygen panel that we have on the left side, same paratroop doorbell there. The co-pilot has control of the master landing light switch. So that's one thing that's unique to the co-pilot side, along with the hydraulic panel. Those couple of things are only on the right side of the airplane. All right, down here we got our flap lever gauge. The pilot not flying will typically operate that. This is all part of our autopilot and flight director, so you can read off what each button basically does, but each one has a function for what's going to be presented on our ADI and the flight director, which then if you turn the autopilot on, the autopilot will get its guidance from whichever button is selected here. We have our rudder trim, emergency trim here, aileron trim. This is all part of the autopilot system. Some more radio. This is where we could put in our squawk, for example, signed by ATC. This is the co-pilot's autopilot setup. The V-speed we calculate at every flight. It's based on weight, temperature, things like that. So we'll brief that. We put a card up, put a toll card up, and we'll brief all those speeds before every takeoff and landing pretty much. Some of the big things that we think about in this airplane are VMC speeds, VMCA, which is our minimum controllable airspeed if we lose an engine. So essentially that's one big airspeed that we want to attain to keep control of the airplane if we lose an engine. Flap speeds are obviously important. We have them placarded here if we need a reminder, but the big ones we shoot for flaps 50 at or below 180 knots. We could also call for flaps on speed if we need to incrementally put flaps in to help us slow down. So if the pilot flying calls for flaps on speed, that basically means we start moving the flaps without exceeding the corresponding airspeed. You can start moving the flaps incrementally to help slow down. Gear down 165. That's a pretty good speed break. You get the gear down, and this thing slows pretty quick. But most importantly, you get the props to flight idle, and this thing, it slows really fast, which is cool.
Yeah, the props kind of act like big frisbees.
Oh yeah,
speed breaks,
yeah, absolutely. We can go from, you know, call it 250 knots to configuration in a matter of a few miles.
Tech Sergeant Ross Peterson, Connecticut Air National Guard. This is our C-130H model. I'm going to go over some things on the overhead panel that I manage. We're going to start with up here on the left, we've got our pressurization, so you can set your cabin altitude and your rate. There's a gauge for differential pressure and your VVI. We also have an ability to manually increase and decrease pressurization and an emergency depress lever or switch. We also have an aux vent position, a no press position, an auto and manual position, depending on what setting we want to use. There's some controls for the flight station and the cargo compartment for the flight and cargo compartment AC packs. We can control airflow to the flight station with this switch here. We can select the temperature controls right here from cold all the way to warm in auto or manual if we need to. Up here we have our APU, so this is how we turn on our APU before we start engines. The APU has 35 psi of bleed air it can provide to help start the engines. We have our bleed air regulators here, one for each engine, 2 positions. We have on and override, on giving us about 45 psi plus or minus 3, and we have a way to isolate the wing by using this bleed air divider valve, which we can close in a case of emergency. We also have leading edge anti-ice, which we can turn on here, which robs some of the engine power to use anti-icing on the wing and the empennage. There's a test light switch for the overheat lights. There is ice detection up here, where we can test the ice detection. We have probes in the number 2 and number 3 intakes for those 2 engines. Next we have our NISA heat for our windows. Normally we fly with heat on the windows. That's how they're designed. Also helps in icing conditions. We have our pitot heat here and our engine ice control for our inlets. We have our master switch here for these switches where we can go to auto or manual if we need to throw it on manually. These 4 are for the prop de-icing, and our gauges will tell us our amps for each phase. Next, coming over here, we have our lighting and then our electrical panel. We have 4 engine-driven generators and a way to disconnect them in case of an emergency. We have 2 BSUs, which provide clean power to the avionics, and we have an APU switch where we can use the APU generator to power the central AC bus on the ground. We have an AC power and DC power. We could receive power through an external power cart, and we have the ability to also use DC power if we need to. Coming over here, this is how we check the frequencies and volts. We're looking for 380 to 420 hertz on each phase. It's a 3-phase A, B, and C. We could check the external power, the inverters, each engine, and the APU frequencies and volts. Volts being 120 or 110 to 120 volts AC, 110 to 125. Sorry. Over here, this is where you select which bus you're checking. Like right now, we're looking at the battery. We've got above 25 volts, so we know that's good. Moving down, we have our fuel panel. So here we have each engine where we can trim out and balance our fuel. We have our cross-feed manifold and then our dump manifold in case of an emergency. We have the ability to dump fuel through our dump valves on the end of each wing. In case of emergency, we need to lose fuel quickly. We have our pump 1, 2 engine-driven or engine pumps, fuel pumps. Sorry. Our aux pumps, 2 pumps for the externals on each side. Another aux pump, and then our 2 engines 3 and 4. Moving to the right, we have our oil coolers, which we can manually control to regulate the oil temperature. Usually we leave those in auto, but we can open or close them as needed. And we have our gauges for each instrument. Going top to bottom, we have our oil temperature, the percentage of the oil cooler flap, and then oil quantity. Moving over to this left side, we have a couple test switches to test the fire detection system and our fire handles. We have one fire handle for each engine, which pulling that should shut down the engine electrically and arm the agent so we can discharge agent if need be. We also have one for the APU. Next, we finally have our start switches, which actuate the starter on each engine. And then we have our fuel enrichment if we need it. And then our elevator, rudder, and aileron boost pack isolation valves where we can isolate different sections of the flight controls in a case of a leak or an emergency of some type.
Good afternoon, my name is Captain Luke Delisio, call sign Oslo. I'm the navigator on the C-130H here. I'll just run you through a couple of our systems we have at my workstation. Starting out from the top left, this is our ski panel. Same thing the pilot has, but has a little bit more of the buttons that we can fly formation and the weather for. Coming over here, we have the compasses. So this will be our left and right compasses, or compass 1 and compass 2. And that's driven off of our INS system as well. And then we have our true airspeed, and then our regular barrel altimeter. Over here is our radar altimeter. We'll set with the pilot, and then a temperature gauge, and then we just have a clock over here. Coming down here, there's all of our defensive systems, and then below that is our ski. Our primary job as a navigator is to manage our our skins equipment for managing our flight management system for the pilots and flying them or navigating the pilots around. This is our radar control panel going into our actual radar screen, and then we control different modes of the radar based off of if we're going weather or mapping or doing offset aim points. And then this is the actual display, controlling the radar through the through our hand controller, and then we'll manipulate the radar for that. Coming on this side, we got our audio control panel. It's the same as the pilots in the flight engineer has, and then our oxygen regulator. Thanks for watching, and thank you for going through the tour of the C-130H, and we're happy to have you on board.